All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. We are going to pick up where we left off last time, although you'll see from the title that we are completely changing gears in the series. So, hey, Singyi, how's it going? So, before I get into introductions and all that other stuff, I do just want to take the first 30 seconds of the video or so and just kind of talk briefly about, the sort of history of the project, where we started, and where we're at now. So, if we go to the Kohi repository, I'll just drag this down here so that you guys can see it. Weird window size, all right. We can see that this has been in development for quite some time. In fact, if I go to our commits, and I think, I guess it's not going to let me sort from top to bottom. But we have been in development of this for quite some time, actually. I think I started this, I want to say, in February of 2021. I'm just going to kind of page through this really quickly. You guys can see all the work that's gone into this engine so far, right? And as we went on, obviously, there was more and more commits, but we have, let's see, we're getting near the end here. Almost here. So here's the initial setup. All right, so the initial commit was on February 28th, 2021. And so we are almost 4 years in to make this game engine from scratch. Now, mind you, this is in my spare time. I put less than full-time hours into this every week. But we've been at this a while, right? And now we're actually switching the series and thus the channel from being a game engine development stream slash channel slash series to a new game development stream, right? So we're going to be we're still going to be working on the engine. The engine's still going to get lots of improvements. We're still going to have to bug fix and still do adding things as we're building out the game. But the goal from here on out is to actually make and publish a game. So from here on out, the game development is going to be taking the front seat, and the engine development is going to sort of take the back seat, right? Because that's not any longer the main focus here. Like I said, we are going to continuously make updates and releases as we develop the game. We're going to need to update the engine as well, but that's just generally the course of direction here. So with that, we've gone ahead and changed the series name, right? And I don't know that I'm going to stick with this name. I might rename it in another stream or two. I'm still thinking about it. But we've reset the counter, as it were, on the episodes back to 1, right? And I'm probably going to record like a YouTube video with a episode 0 sort of edited introduction, right? But we technically kicked this off last night, but we are actually going to dive into this full bore tonight. So before I catch up on chat, I do just want to take a quick second and thank the supporters of the channel, starting with our elite partner, Javier Olazaron, and our partners, Gerboles Inc. and Matt Osgard. Those are the top 2 tiers of subscription over on Patreon and YouTube memberships. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated, and that money will be going towards this project because we're going to need it at some point. So, with all that said, of course, without you guys, the viewers, whether you're here joining me live or whether you guys are watching the VODs after the fact, this project would not exist without you guys. So I appreciate each and every one of you. Thank you guys for being here. All right. So that's sort of the long-winded intro, I guess. But that's kind of where we're at tonight. So let me catch up on chat, and then I'll go over another quick change here that we have to discuss. RCW, good to see you. Rude Rich, good to see you as well. I was official. It's been a minute. How are you doing? Trash Can, it's good to see you as well. Foxy Game Dev, good morning. It's definitely evening here, but depending on where you are, I suppose it could be morning if you're in like Japan or something like that. But yes, good morning to you as well, and welcome as a first-time chatter. Okay, the other thing I wanted to mention is last time we were on Windows. Tonight I'm actually on Linux, and I figured out what some of the issues that I was having with hangups and stuff that was going on. It was actually the windowing system that was causing problems, because I noticed that it was like when I changed focus to and from that window, like the windowing system itself was freaking out, and it wasn't even just that; it was like Firefox was doing it as well. And so, yeah, I've gone ahead and changed over to KDE as my desktop environment now, and I'm actually using Wayland, and it seems to work just fine. So that's good to know as well. Tamin, thank you for the Prime sub for 12 months. Oh, it's been a year. That's awesome. Thank you very much. Thank you very much for the support. It has been a year. Yep. Foxy Dev, thank you for the follow as well. All's good, lots of work, but glad being here with all of you this game. Awesome. Well, I appreciate that, and thank you guys for the follows. This game's going to be amazing. Yeah, so I actually have some other ideas to talk about on it, right? But I kind of want to get like the first, most basic mechanic in and working first. So that's what we're going to work on tonight. You can actually see some code here on the screen that I started banging out off stream to kind of get a head start on it, right? So, Bytemap over on the YouTube side, how are you? Hello. Okay, what we have here is I'm actually just going to debug this real quick. I'm not going to build because the build's actually broken, but I want to show you guys where we are at currently, right? So last stream, we kind of got the ability to toggle back and forth between sort of a world mode that's kind of tied to the gameplay and things like that. And then we also have an editor mode, and we had the ability to hit the C key and transition between two different cameras, one camera that we can move by ourselves to sort of fly through the world in like an editor-like mode, and then another camera that is sort of tied to a world object that doesn't yet exist, but that's the way that's going to work. And so we got that tied in. I did a couple of small modifications to show what mode we're in here down at the bottom. And I also added runtime here because that is kind of an important metric to know, right? And we'll probably work that into, at some point, we'll probably work that into like the logging, right? Because that may be important at some point. But offline, I was also doing some tests, leaving this running for a couple of hours, just so I could kind of get an idea of what was happening, right? So we have that, and I also got the loading of a basic scene, right? So this looks very familiar to you guys that have seen the testbed application. I basically only kept this tree model just so I could verify that was working. That's not going to be there very long. And then we also have a water plane in here, and that's all that's in here, right? And so if I switch to the editor mode, we're in a different camera. Oh yeah, I did add an audio emitter in here as well to test that, right? And so we've got a couple of different cameras that we can switch between now, and it's really obvious, what's going on there, right? So the other thing is I got the console working, but I don't have any commands hooked up to it yet, but it's in there, right? So we'll eventually be adding console commands to the application as needed. But this is our starting point for tonight. So with that being said, I want to go ahead and talk about the way that I envision this track working before we actually take a look at the code. So I'm just going to grab this and bring it down here. All right, and we're going to do a little bit of drawing so we can talk about the design of this and how it's going to work. So let's start off with green, right? So essentially the way that this is going to work is we are going to have our track is initially going to be represented by a series of points. So we'll have, a couple of points, around the world, right? And what we're doing right now is we're actually looking. This is like a top-down perspective, right? And so each one of these points is going to have obviously a three-dimensional position in space, and they're also going to have a couple of extra values. So they're going to have a left width, right? And they are going to have, you know what? Let me use a different color for that actually. So they're going to have, no, you know what? I'll stick with green because it's kind of part of the point, right? So we have a width off to the left, and then a width off to the right, which can be a different width, right? So this is always going to be a straight line. That line to the left and right is always going to be a straight line. And we don't really need to ever modify that, I don't think. And so that's what I'm going to stick with. We are also going to have the ability to, at the end of these, specify a height, right? So we're going to have a height available for the left and the right that could differ from the center, right? So you can already see how this is going to kind of build out our geometry. So we're essentially going to have a bunch of these things, right? And obviously this is not to scale, right? It's just to kind of show the way that all this stuff's going to work, right? So we might have one that looks like this, and then we might have one over here that's a little bit less even, right? That maybe is, whoops, that maybe is, you know, something very cattywampus, right? But we might have the need for that, right? And so what we're going to do is we are going to then specify, or we're essentially going to take a vector between each one of these segments, right? And that's going to provide us with the center of the track, right? And then what we're going to do is we're going to say, all right, well now we're going to have a boundary that we can't go outside of, right? Along the track, and that's going to be these outer points, right? And bear in mind this, you know, all these points can go up and down on the y-axis as well, right? So this is basically what we're going to wind up with two segments. Now, in each one of these, we also have the ability to split this up, right? So we could actually split this into sub-segments if we wanted to. And then we can, you know, kind of interpolate and eventually add some curvature to it and things like that, so we don't have, you know, sharp bends like this, right? And eventually we'll be able to grab all these points and rotate them and set the heights, you know, in the world on all these endpoints and things like that. And that is basically the way that the first version of this is going to work, right? So this is what two segments would look like. You can imagine it going around and up and down and around and eventually looping back onto itself, or maybe not. Maybe we have tracks that don't do that. And so you're essentially going to have a collection of these segments, and the vehicle will be bound to that area, right? So it won't be able to go outside of that. And we're not going to need a physics system to do that. We are just going to use some trig to actually handle this for us. So the first step of this is going to be just getting something to slide along that surface, right? And so we're generating now the code to get that to work. And then we'll go ahead and do things like have extreme, you know, upward and then drop off so that we can jump. And we'll have like a gravity that we can apply. And you know, we'll just kind of keep iterating on it as we go. And then, yeah, that's pretty much the plan, right? And then eventually we're going to add obstacles within this and make it a little bit more high resolution and stuff like that. But that is kind of the plan in terms of data structure. So let me just catch up on some chat here. Super excited to see how Kohi has grown and is now moving forward with the game. Yes. I appreciate the kind words there. Thank you. Hello, do you have any experience with C++? Yes, enough to know that I don't want to use it. Vincent, good to see you as well. Dingus Dev, thank you for the lurk. Kakali Saha, I hope I pronounced that right. Hello. Mean Mr. Mustard, good to see you as well. LaForce, welcome. It's your first time in the stream. Thank you for the videos. Do you know when the next devlog will be dropped? Yeah, that's been a bit of a point of contention. I just haven't had the time to edit them, frankly. So what I'm gonna have to do is the original format that I did for that is not necessarily going to work, just because I was only covering about 10 videos at a time. And we actually just started this series, but the series for the game engine ended at 263 videos. And I frankly just don't have the time to edit that many videos, right? So I'm going to have to compress it a little bit and kind of gloss over some of the details once we get further in. Yeah, it's basically, I'm kind of choosing between do I want to keep pushing the game and the engine forward, or do I want to edit video, right? It's one of the reasons I switched to live. But to answer your question, I don't really have a time frame on the next devlog being dropped, but I know I need to do it. All right. Apotham, how's it going? Welcome. Okay, so this is our track system, right? So just to recap, our track itself is going to be defined by a series of points. That's these green things here. Each point will have a position, a left width, a right width, and a left height and a right height. And then a orientation or a rotation around the y-axis, right? So that's how we can get these points here. And then we'll essentially interpolate between those. And we're going to use that both to generate the geometry as well as actually performing our collision, which is really just us sliding along that surface along the way, right? So we'll see how that works. We may wind up needing to do something different or more robust down the road, but at least this is a good start for us. Been good. Just restarted working my 2D game engine in Odin today. Nice. How are you liking Odin so far? I've heard mixed opinions. Some people love it. Some people are just like, I might as well just use C. Let's see. The refactor episodes are 60 you can cut off for the devlogs. So, I mean, yes, but it would be important to cover what those changes were and why they were made, right? So I wouldn't cut them off, but yeah, I could definitely condense it. Awesome. Good luck for the game. I appreciate that. Thank you. Can keep the 10 videos per devlog until episode 80 where you switch to live streaming. Yeah, exactly. Yeah. So you're probably right about that. I could probably stick to it until about then. Then do a devlog per improvement. That's true. I could do that up until I reach the refactor part, and then I might just make one devlog for the whole refactor, frankly. And then it'll mostly get us caught up, actually. All right, so let's talk about types, right? So I started kind of banging together what this track might look like, right? So we have a track structure that right now has two things in it, a array of points or a D array of points. And I went with a D array there because I want this to be editable. So we need to be able to add and remove points, right? And then we have geometry that we're going to use to visualize the track, right? And so the track itself is really only going to be used for collision, right? This visualization that we're adding is not how we're going to actually render the world. I don't think we really need to do that. I think we can actually just model some things and model out the scene in Blender or something and get something that's really nice looking, and then just sort of edit the track to make it fit it. All right, let's see. Used Odin a bit now. I really like it. Like the built-in array as vector functionality. Yeah, I've heard, that is pretty nice. Let's see. Okay. Will this be ported to mobile devices? This game will not, no. Only because I don't have a backend that's capable of running on mobile right now. So the goal for this is to I mean, we might port it to mobile devices later on, maybe. But for right now, no. Certainly not when we release it, right? The goal for this is to get a first game complete, built with the engine, and release it. And my plan right now is to build it and release it for, at a minimum, Windows and Linux. Mac OS, I'm a bit iffy on because it does require Molten VK to be installed in order to actually play it, which I'm not a huge fan of releasing it that way. So that one I might hold off on. Super cool to see. This is super cool. It's great to see the engine has come along to this point. Yeah, it's pretty exciting to actually be here. Hello, I'm trying to learn game dev, but I don't know what language to use. Which language do you recommend now, and what do you think of Jai? I want to use it, but it's in closed beta. So I'll give you, that's kind of a loaded bunch of questions, but I'll give you a quick answer to that. I can't speak on Jai because I've not used it. I don't really have an interest in using it either, just because I prefer C. That's my preference. If you don't know C or C++, I would say for game development, you should probably learn that unless you're going to use Unity, then you want to use C#, right? But you probably ought to still know C++, in my opinion, because everything else uses that. However, I would say that if you don't know either of the languages, learn C first and then learn C++, because it'll set you up to learn C++ a lot easier if you do C first, because it'll force you to understand some of the concepts that C++ tries to sweep away under the rug. And so, yeah, it's that would be my recommendation there. Yeah, I hope that helps. You could try Odin. It's similar to Jai. Yeah, you could try Odin as well, but I don't know if like a full game has been released on Odin yet. And it's certainly not used in the industry, so it really depends on like what you want, what your goals are, right? All right, so like I said, we have our track, right? And the way I'm going to implement this right now is quick and dirty in the game code, and then we might move it to the scene, although I think the track itself is more of a logical thing, and the rendering of it is really only for debug, so I'm not thinking I'll ever actually put it in the scene. Maybe, but probably not. So we have our track here, so that has the points, and then the geometry, which is really used to just visualize, where it's at, so we can actually see it on the screen. And then our track points look pretty much like what I described, right? So we have a position, a left width, a left height. That's a height difference from the center on the left side, right? So that's relative to the center position. So it's relative to position.y. So we have a left width, left height, right width, right height. And then we have a rotation y. We only allow rotation on the y-axis. And the reason for that is because we don't really need rotation on like x, right? Because we can control the height, right? On y, and we can control the rotation, which gives us that x rotation. So we don't really need any other rotation except y. So that's what we're going with there. And then what I've done is over in the track here, which has got our typical create, initialize, load, unload, destroy lifecycle stuff. We have our create, which for right now, I'm just kind of doing some hard-coded stuff just to kind of get something on the screen and get something loaded up. So we've got a track with 4 points right now, which essentially means that we're going to have 3 segments, right? So that's essentially one more than this. Like it's literally like if we did, something like this. Right? And this is not to scale either, but just to give you guys the idea, it's whatever the number of points is, the number of segments is number of points minus 1, right? And if you look at the way that this is visually, you can kind of understand why, right? So we have, let me get rid of this just for clarity. So we have, 4 segments here. 4 points, right? And 3 segments, the segments of these boxes. So each segment is going to be made up of essentially two faces, initially at least, with the ability to sort of tessellate. And so the idea here is that we essentially generate a vertex at these four corners of each one, and then two more in the center, right? And we do that for each one. And then as far as the calculation of like the movement and stuff, the only thing we actually need are the points themselves, and we calculate everything else based off of that. So we generate our 4 points here. And this is not actually complete. I only started writing this, right? So we have a lot to kind of go through. I'm actually working out how to generate the vertices right now. And I think I've got it figured out mostly. So actually I want to set segment resolution. I'm going to set that to 1 for right now. Because I only want 1, right? And then we'll pump that up later and see what that looks like. But just to try it out, we only want to have a segment resolution of 1, which essentially means we have 1 face per segment side, right? So we go, our segments are defined by our points, right? So we just kind of traverse the list of points in order. So we do a for loop with point count -1, right? Because the last point, does not have geometry after it. It is the termination, right? So our segment count is point count -1. And so here is where we start to calculate that stuff out. So what we do is we have the start and the end point. We get a vector along that segment. And then here I've set this up to allow us to tessellate it, right? According to our resolution here, but I've got that set to 1 for the time being. So essentially the way that this should work is we should get 0 the first time and 1 the second time, and then we should be able to go through here and generate geometry as needed. So essentially what we do is we get the left width, the right width by taking we interpolate between the start and end widths, right? Using that interpolated value along the way. So each one of these, we kind of interpolate between those 2 points. So we do that for the left width, the right width, and the rotation along the way, so that we interpolate the rotation as we actually go. So what that basically means is we will have, let me bring up the correct one here. So essentially what that means is like, we'll use this one as an example. I'll use a different color here. So it means that the segments will look, something like, this. And again, this drawing is not to scale, right? So don't judge me, right? So it'll wind up, splitting it up, something like that. All right. So this was kind of where I left off, where we have the I've generated the left and the right vertex along that point. And then the center is actually just going to be the center, right? So that's based off of the start position interpolated to the end position. So we do need to actually define that, right? And so all that's going to wind up being is, well, let's see, actually. So the center is already interpolated, actually, so we don't actually even have to do anything there. Okay, so we have to store this in the vertex array, which means we need to think about how we're actually going to generate our vertices. Now I'm thinking we should probably go left to right when we do this. And so if we do that, we're going to do, we'll just think about this single segment here, right? Let's see, isn't there a type thing here? Yeah. Okay, so if we go left to right, then that means that we're going to wind up with, I guess let's use this color. We'll wind up with having this is index 0, right? This is index Did it not? This one would be index 1. This one would be index 2. And then up here, this would be index 3. Sorry, not index, vertex 3. I keep saying index, I mean vertex. This one would be 4. And then finally, this one would be 5. Whoops, if I can. There we go. Right? But obviously, we need to split this into triangles as well, right? So we're going to need to do this in such a way where it actually makes sense, that where we can generate it in triangles. So maybe this isn't the best order, because we'd have to kind of skip around a little bit. Maybe we should do... No, I think that'll be fine. Because, for example, we'd want to go counterclockwise, right? So we go 0, 1, 3 would be the first one. And then we'd have 1, 4, 3. And then we'd have, 1, 2, 4. And then, 2, 5, 4 or something. And then once we figure that out and we get the indices right, we should be good. So I guess I'll go ahead and we'll generate all the vertices first, and then we'll figure out what we need to do for the index data. Okay, so I guess what we can do, since we have 3 of these, we basically just need to figure out like an index offset. And so initially I was thinking we offset into the vertex array for 6 if we have, which would be fine if we have just a single segment, right? But that's not necessarily the way this is going to work. So let's take this out of here, because I think that's going to wind up confusing us more than anything. So we'll put it out here. U32V, and that's going to be we'll say vi, right, for vertex index. And we're going to start at 0. And then as we go through the segments, each one of these is going to define 3, right? So here we can do v plus equals 3. So vi, rather, plus equals 3. And then we can basically say that, I guess we can put it down here. Let's see, we can do T geometry vertices V. We're gonna have to cast this, aren't we? Yeah, we are. Okay, let's do this a little bit differently then. Let's cast it first up here. So we'll say we're using vertex 3Ds, by the way, right? So we'll say vertex 3D array, and we'll say verts is equal to T geometry vertices, right? Vertex 3D. Okay. That way we don't have to cast every single time. So we can come down here, we can go verts, and then we'll do index of vi, right? So that's going to be the first one, is going to be, let's see, the position is going to be equal to left. And then verts vi plus 1 dot position is going to be equal to right. And just to align this visually, I'm going to do plus 0 here, right? And then verts, you know what? That should be center. And then right. Position equals right. Right? So we do that, right? So we store 3 vertices at a time, and then we move that vertex index up by that amount. Okay. So we do that for each one of these each segment, and then each tessellation within that segment. We do that, right? When we get to the end of that is when we actually need to generate the index data for the segment, right? So this is vertex data. So that is pretty much straightened out. The index data is going to wind up taking, let's see, the resolution. Let me think about this. This needs to be less than or equal. And this should be R, not 0. Typo. All right, so R equals 0. R is less than or equal to segment resolution, which in this case is 1. So that means that's going to loop twice, right? It's going to generate 2 sets of vertices in the default case, which is what we're going to test first. So the index data needs to also be based off of the segment resolution. But I wonder if I can cram it into the same loop. I would have to do that retroactively, I guess. Because we couldn't do it on the first iteration, right? So if we look at our drawing again, just thinking about this logically, if we generate these vertices and then we generate these vertices, in order to triangulate, right, and be able to generate our indices, we need these to actually exist. Now we know that they will exist. So I suppose we could do that and then just not do it on the final iteration. But even that, we either need to skip the first iteration and look backwards, or we need to skip the last iteration and look forwards. I feel like that's a little bit more intuitive. I feel like that should be fine to do, right? So we would need the first index to just be no offset, the second index to be offset by 1, and then the third index to be offset by 3. Essentially what these are. So what I'm thinking is, if we do, let's see, I guess we need like an index array index, right? We would need, I guess I could actually, I think I could move this in here. Yeah. And what we'll do is we'll do index plus equals 6, right? Because we're going to generate 6 at a time. And so what we can really do here, we don't have to loop through this twice. We can do it all at once. I'm thinking. So we need to cast our indices as well. So U32 indices, right? And that's an array of those. Equals U32 array T geometry indices. All right. And so here we can say indices, and this is going to be index for lack of a better term plus 0. And that is going to be equal to, what is it going to be? It's going to be 6 times we don't want to do segment resolution. 6 times R. We want to do 6 times R, right, for each one of these. And then we want to add to that basically the offset of the entire segment. which will be, so that's for each individual tessellation. So that's going to wind up being 6 per tessellation times segment resolution. I'm not 100% sure I have that right. So let's walk through this logically really quickly. So we come through on the first loop. Everything is 0, right? So we're going to say index offset 0 is equal to 6 times r, which is 0, plus 6 times segment resolution. That's wrong, because it should be 0. This should ultimately come out to 0. Let's see. I got some chats to catch up on. Let me do that. Let's see. Just realized that we're talking about a game different from last time I was here. Yes, we are in full game development mode now. We are no longer the engine is no longer taking the front seat. It's the engine, or it's the game now. Sukelos Music, good to see you. Hello. What's on the workbench for tonight? So we are starting the game, and we're actually generating geometry for a track, right? So it's like a race track that we move our vehicle along. And so I've done a little bit of work offline, and we're trying to generate our vertex and our index data so that we can actually render it, so we can visualize what it looks like. And then we're going to work on getting an object to be constrained to that, the bounds of that track. Thank you for the follows, by the way. Let's see, I've seen some videos related to data-driven development recently, and one of the things they said about that was bad about OOP, having big inheritance chains and virtualization because of performance. I've been getting back into game dev recently and trying to actually learn it this time. I was wondering what options do I have if I was trying to avoid using virtual classes. Example, need to use a different implementation of a window based on OS. So what I did is I have a struct that I essentially use that I keep an opaque pointer, and I keep the platform layer info behind the platform layer, and that's sort of like an internal data that I use for the window, right? So instead of having like classes and all that stuff, I have like a opaque pointer to the actual internal data that the platform layer needs to know, but it's all kept at the platform layer, and I don't let it escape that. And I use that pattern a lot. I actually want to switch that instead of a struct. I actually want to switch it to handles, like I've been doing a lot of other things. But yeah, if you take a look at the code base and you take a look at the platform layer, you'll see what I mean by that. But yeah, that's one thing that I do to get around that problem. How the heck do you learn Vim motions with a blank keyboard? Bro is deep in flow. The longer the beard, the better the code. Yeah, hopefully. I mean, I don't have a blank keyboard. My keyboard is it's lit up, but yeah, I don't know how. I mean, I don't ever really look at my keyboard too much though, so I guess it's kind of the same. Spiro, thank you for the kind words there. I appreciate that, and the 20 bits. Can't believe you're finally making the game. Long time coming, bro. Yes, definitely. I appreciate that. All the greats donned beards. We'll see about that, right? Good to see you started developing an actual game. Good luck. Yes, thank you. Appreciate that. Yeah, I can't believe I'm actually finally doing it either. Let's see. Hey, do you or anyone in chat have any tips on moving from OOP C++ to C? I mean, there's lots of tips for that. It's not just really like one tip, right? But I think the biggest thing there is trying to get out of that mindset of having to have everything broken into these little tiny objects, right? And I still find myself doing it every once in a while, but C is probably the best way to break away from OOP that you can get, because C doesn't have OOP really by default. You can kind of fake it, right? But build a simple project in C. Recommend the video How to Program in C. Oh, okay. Yeah, I mean, that's fair. What I usually tell people that are wanting to learn C that usually don't already know C++ is I tell them to write a string processing library. Because that teaches you just about everything you need to know in terms of working with C. And if you do that, by the time you're done with that, and maybe a math library, you'll be pretty comfortable with it, I think. All right. Okay, so this is this was not correct, right? So we need to figure out. Let me think. This needs to also take into account segment resolution, but it needs to be like the 6R is going to give me the proper offset into the. Oh, wait a minute. Should this be? Shouldn't this be I times segment resolution? Or R? Actually, I think this one. So if we want to think about the total segment, right? We have. Actually, I think this is just going to wind up being R, right? Because R is where we are in the current tessellation. Let me rename this. Do we have... I can't use T, because that's track. I guess... Just to remind myself what we're doing here. Oh wait, no, this is, yeah, see? This is the tessellation right here. So vertex data is going to be here. There we go. Okay. So for each tessellation is going to wind up being 6 indices. Right. So we're going to want R times 6 is going to give us the... No, R times segment resolution, right? R times segment resolution plus... Thank you for the follow. Yeah, R times segment resolution will give me the total offset. Right, so for the first iteration, that would be 0. And then, what do we want? We want plus R? That doesn't seem right either. Well, I guess this first one, no, this first one would be plus 0, right? Because we want this guy. So the plus needs to be this. So it's what segment number we're on. Segment resolution, that is, no, that's not right either. Do I even need that actually? Or should I be using, maybe I should be using this. I'm not sure that this is the way that I should be doing this. Let me think this out a little bit more. So the next one's going to be 1, right? So we want 1 there. Let's at least get this down, right? So we have 2, right? Index 3, 4, and 5. And then we said our order was going to be what? 0, 1, 3. Oh, we're going to need a lot more indices than 6. We're going to need 12 indices per segment. Okay. So we want to do 0, 1, 3. 0, 1, 3. And then 1, 4, 3, we'll say. So 1, 4, 3. And then we actually need another set of these. Right, so this is going to be left. This is going to be right. This is going to be 7, 8, 9. Whoops. 10 and 11. Okay. And then what's so we want to do 1, 2, 4. Wait, not 1, 2, 4. Yeah, 1, 2, 4. 1, 2, 4. And then 2, 5, 4. 5, 4. Thank you for the follow. Appreciate that. Problem-oriented programming, if OOP fits, use it. It just doesn't a lot of times. But like a lot of things, you know, with absolutes don't always tend to be accurate either, right? Thank you for the follow. Appreciate that. String library in C seems a really good option to learn C, in my opinion. At school, we had to write a lot of the standard library, string functions included. Yep. Hey, I'm at video 25 from your series, and I'm loving it. Awesome. I appreciate that. I'm glad it's useful to you. Raylib in C is a great start. Yeah, I would agree with that. If you're looking to hit the ground running, for sure. Okay, so this is technically, this looks forward to the next, I don't want to say segment. Tessellated face, I guess. So skip the last iteration, right? So we need to surround this with a conditional check. We need to say if R equals segment resolution. I guess it's if R is less than segment resolution is what we really want. Then we need to do that, right? Okay, now, so we have these are going to be correct if I actually take this and make it plus 12. Which means actually, did I point count times 12? This needs to be times segment resolution. Oh, I put segment resolution in the wrong place, right? 2 faces per segment tessellation. All right. Okay. So if we have, R is not going to be what I want here. I think what we need to do is we need to use this. So if we do the index offset, no, it's going to be the vertex offset is what we want, not the index offset. So for each one of these, we offset the vertices by 3. So should this be R times Vi? Or just Vi, maybe. I think that actually makes sense, just Vi. Right, because this is already offset into the array where the vertex needs to be. So if we use the vertex offsets, yes, and that does look forward. Actually, yeah, it's a little bit simpler than I was thinking. That almost feels too simple. So really, that's what we're looking for. It seems too simple, but I'm going to go with it. We're going to see how foobar it is. All right. So we have our vertex data, our index data. I'm not 100% sure this is right, so we're probably going to have to come in and do some debugging in here just to figure that out, if it's correct or not. But so initialize is where we're going to generate our geometry data. Excuse me. So track load is where we need to upload that to the GPU. So first off, we're going to have to check if there's no track, return false, right? Because that's definitely no bueno. And then we'll just come down here and return true. And then we basically just need to take that geometry data and upload it to the renderer. So we'll do renderer geometry upload, I think is all we need to do. And we could do the address of T geometry, right? And we'll test that. We could probably just return that value, actually. Return the result of that. I do have this marked as deprecated. I think I'm going to undeprecate that, right? Because this winds up actually being kind of useful. The only thing I don't like about it was the fact that we had material in there, but it's no longer in there. We decoupled that. So I might actually go and make that so it's not deprecated anymore. But anyway, so that's all we should need to do to load it. One thing we don't have, we don't have any normals for this. We don't have any, tangents or bitangents or any of that stuff. And I'm going to hold off on generating that now. I just want to see if the geometry is correct, right? And then we can kind of look at it after that. So track unload, we'll just check to see if the track exists. and then render geometry destroy. And we'll just do the address of T geometry. And that's pretty much it there. Track destroy. The only thing we need to do here is basically just undo the allocations that we made up here. So what I'm going to do is I'm going to take these and copy pasta that. Actually, let me check. Does render geometry upload? Does that? It does increment the generation. Okay, cool. You know what? I'm just going to undeprecate these now, because we are going to keep them. I was thinking about getting rid of them in a previous version, but I'm not going to. All right, segment resolution. We're going to have to... I guess we probably ought to store that then, if this is going to be... Let's store that on here. So let's do U32 resolution. How many times each segment gets tessellated? And we'll do, instead of setting this here, we'll do T segment resolution. Okay, so we've got segment resolution. Oh right, we don't need that down here. All we need to do is do k free. Take this. Put that there. Take this. Put that there. And then change that to free. And there we go. I guess we could also do, you know, if T, we'll be safe about it, right? And then we'll do if T dot geometry vertices. And then we'll do this. And then if T geometry indices, and we should probably do T geometry index count, right? We should probably do vertex count, right? Then we'll do that, and then we'll do T geometry vertices, or vertex count, I guess, equals 0. T geometry vertices equals 0. T geometry, actually, we don't even need to do this. You know what? In fact, let's just, whoops, did I did screw that up. Did I get that right this time? There we go. Why is this? Oh, I see what happened. There we go. Okay. So let's get rid of this, and then we'll just do a 0 memory on T size of track. Right, and then we can do track geometry generation equals invalid ID U16, I think is what that is. Yes. I don't think there's anything else on there I need to make sure is set. Yeah, that's fine. Okay. All right. So that's the destruction. And then this other stuff down here we're not going to worry about yet. That's the collision stuff. I kind of started thinking about how this stuff is going to come together too. We'll go over that when we get there. All right, that's no longer a to-do. Let me see. I did hear a ding, so let's see what's going on here. Dr. Elliott raiding with a party of 5. Thank you so much for the raid. How are you doing tonight? What'd you get up to on stream? I know we were talking a little bit about some Vulcan stuff. How is that stuff going? And welcome, raiders. So locked in, you never reach chat. No, I do. What I do is I kind of do it and I like code for a little bit and then I stop and I read chat and I catch up on it. Usually so that I can complete my thoughts, because if I fragment it too much, then I'll forget what I'm doing, and that's happened a few times on stream and it's not great for anybody. Let's see. He has a Pomodoro timer hidden in his beard to know when to read chat. I mean, maybe. Probably read now they had a ding. Yeah, sometimes it's the audio that like snaps me out of it, right? It's dingus. Yep, exactly. Vulcan goes like Vulcan goes. Yes, it does. Dingus, exactly. Yep. Dingus-oriented development around these parts. That's what we do. Am I using Emacs? No, I'm using NeoVim. Yeah. Well, welcome, raiders. For those of you who haven't been here before, I'm not sure if you guys have or not. This channel up till now has been about making a game engine from scratch. We are moving from, or we have moved from making a game engine from scratch to actually making the game. So we're actually starting to implement some of the systems and things that we're going to need to get our game working. So one of those things is it's kind of like a combat racing kind of game / endless runner kind of deal, with melee and range combat, that kind of thing. And so one of the things we're going to need for that, the very first thing we're going to need for that, is a track to actually run on, right? So that is what we're making now, and I'm working on figuring out what we need to do for the geometry to get that generated based off of the data structure that we have for our track. Do you get Emacs Pinky if you use Emacs? I honestly haven't used Emacs enough to know the answer to that question, but I've heard that. I've heard that the ergonomics of the default keyboard shortcuts are absolutely atrocious for Emacs. For me, it's Vim bindings all the way. Better to stay on the evil side, yeah. Yeah, that's pretty much what I've heard too. Okay. So I think this is as far as I'm going to take this for now. We should have everything that we need in order to actually generate the geometry and ultimately draw it. So what we're going to do is we're going to switch back to hitting the wrong keyboard shortcut. Speaking of keyboard shortcuts, hitting the wrong one all the time, but that's because I'm a dingus. All right. So we'll go back to the main file, and we'll go ahead and put, I guess we'll put all of our game stuff here, right? So we'll do an include, and this is going to be track H, right? And now we're going to need to go to our game state, which I renamed game state, by the way. It's less verbose. So our game states looks like this currently. And we're just going to kind of feel this out as we go. This is probably going to wind up being a pretty large structure by the time we're done with it, and that's okay. We may wind up splitting out parts of this. I haven't really decided yet, but if it comes to that, we'll do it, right? But I don't want to do that preemptively. Okay, so we have our scene there. And for now, I'm actually just going to put in a track in here. And we're going to say, I can't call it track, right? I guess we call it collision track, because that's ultimately what it is, right? We need our H file here as well, which technically means we don't need it in. We technically don't need it in the C file anymore, but that's fine. All right. So application boot, we don't want it there. Application initialize is probably probably not where we want it either. If I'm honest, we probably need to go to load scene. So what we do here is we initialize the scene, right? And then we actually load the scene. So we're probably going to want to plug in between here. So what I'm going to do is I'm just going to jam a hack in here for right now. Initialize track, right? And actually we have the create here as well. So it kind of fits in nice with this, right? The overall life cycle of it, right? Create track. And then down here, we're going to do load track, right? So we'll do if not track create. There we go. And we want to put this in the address of state collision track. So if that fails, failed to create collision track, and we'll return false on that one, right? Or just return rather, because this is a void function. All right, so we have create, initialize, pretty much going to follow the same pattern, and so we'll load. So I'm just going to copy pasta those in there, and we'll do initialize, and we'll do load. And again, we'll do this here, and then initialize collision track, okay? So that is what we need to do there. And then the other thing that we need to do is when we actually go to prepare this for rendering, right, we need to actually make some render data to actually tell our render graph to render the thing. So what we're going to do there should be pretty straightforward, I think, actually. We want to do prepare frame. And right after we... I really need to change this too. This is bad to be doing every frame, but I really need to rework that. Let's see. So forward render graph node. So we do a bunch of querying for our mesh render data, right, which is here. And so I think we're going to actually just, we're going to jam this in with our static meshes. We're going to treat this like a static mesh in order to actually do that. So let's see. We have our geometries here. We have a D array that we reserve with the allocator. We've reserved 512 spots for that. I don't think we're going to need that many, but I'm going to leave it there anyway, because that's just done with the frame allocator. So here we do our render query, and what this does is let's see, we want this function. So all this does is it comes through here, makes sure that things actually are within the culling frustum and all that. I'm not going to worry about that for this. We're just always going to draw it because it's debug, right? So I'm not really too worried about that. What we need is this bit right here. So it's essentially this, right? And so we are going to put in another hack, right? Let's see. Geometry counts. Yeah, so let's do another hack here. Hack. Geometry render data for the collision track. Right? And I'm just going to pasta this in here, and we're going to just take what we need and delete the rest. So we don't have to worry about the transparency check. We're not going to do that. All we need is just that DArray push and then the drawn mesh count ++ in there, right? So we're going to do model. So this is the model matrix, right? So we're just going to do mat for identity for now. We probably should cache that somewhere, but for now I'm not really too worried about it. The material. So the material, we need a material instance, right? So we're going to have to get like a default material instance for this. So we are going to have to load that up somewhere, probably in the track as well. I'm not going to worry about what material it is, just the default material is going to be just fine for that. Because we don't care how it looks. It's only a representation of the actual collision that we're rendering with this, right? The actual way it's going to look is going to be modeled out later in like Blender or something. So I'll come back to that. Let me do so state collision track geometry, and then you know what? Actually, I can shortcut this a little bit. Let's do this. Let's scope this. Right. And instead of incrementing p-frame data of drawn mesh count here, let's do geometry count ++. Okay. So we're going to want k geometry g equals the address of state collision track geometry, right? That way we can just reuse these things that we have here. So that takes care of those. I'm not really worried about per pixel selection. I don't care about that, so let's just delete that. Winding inverted is going to always be false because we're not going to have a negative scale on this. We're not going to apply scale to it at all. And then we're going to push this to, let's see, just geometries. Okay, so the only other thing we need to do here in order to actually be ready to go with this is we need a material, right? We do need a way to actually store material. So let's go back to the track for a second. Track. And we'll actually go to the track itself. And we're just going to do a material instance. There it is. And we'll do material. Right? And again, it doesn't really matter what material we use here. It really does not matter. Okay. So in track creates, probably during track load is when we're going to want to do this. So we can do material system. Let's see. Get default standard. There it is. So we need engine systems get, and then we need material system for that. This does return a material instance, right? So we can do t material equals that, right? We're just going to get the default instance. We're going to get an instance of the default material, rather. And now we can come back over here and do state collision track material, right? So that winds up getting pushed into there. That should get inserted just like we do for the regular static mesh geometry. And I think if we haven't foobarred anything like out of bounds or anything, we should see something I'm not confident it's going to be right, but let's build and see what we got. All right, so I need this one. All right, so we'll load. And we'll switch to our editor. Now I don't see anything. Let's check the logs. Here's all of our shaders. Okay, so I don't actually see anything in the logs. Am I missing something here? Breakpoint time. Let's see. This is around line 649. Let's see. Set a breakpoint here. Okay, so probably ought to set it. Let's set it before we actually push into it, right? So we have all the properties set so we can actually take a look at what this is doing. Okay, so the model matrix should just be identity. Yep, it is. Okay. The material, I'm not really too worried about that because if that was wrong, we have fallbacks for that. But that looks valid. Okay. Draw ID, unique ID, winding inverted is false. Diffuse color. Oh, that might be a problem. That's probably why we're not seeing it. Because we're not setting. I don't know if we're actually using that. Do we actually use? We'll just set that to pure white. I don't think that's what the problem is, but let's disable this for a second. Let's get rid of this. We don't need that anymore. It's not below the water surface, is it? No. It should be around here somewhere. So let's see if we can't figure out. Yeah, it's not below here either. All right, let's turn this back on. Let's see. Oh, vertex element size is 0. And index element size is 0. How did that happen? Because we didn't copy it over like Dingus is. That's why. Vertex element size equals G vertex element size. And then data index element size equals G index element size. Let's do nope. Did I forget a step here? I feel like I did. Okay, let me look at, actually, let's look at scene. Let's see. Let's actually look at the static mesh system. That's going to be a better. So when we load, on resource loaded, all we do is we acquire a material for it, for each submesh. word upload isn't even in here. Interesting. Okay. Geometry, vertex count, vertex buffer, offset. Did we do that? Maybe we did it in the resource handler. It's been a while since I've looked at this, actually. Okay, so static mesh on result. We do upload this the hard way. So we do render buffer allocate, load range, all that stuff, which I think is what this does under the hood. Pretty sure anyway. Initialize, load. Render geometry upload. Yeah, it just does all this stuff that's over here. So that should be, let's see, let me just make sure that I'm not doing something idiotic in here. It's not a re-upload because I set the generation to invalid ID U16. I think we did that up here. Yes, we did that. Okay. So it should have done all of this. What's its generation, I guess? That should also tell us whether or not it was successful. We gotta go ahead and run again. Okay, generation is 0, so it flipped back around, so that's good. Vertex count is 24. Vertex element size is 64. That seems right. Index count is 48. Okay, so this seems correct. It's got valid offsets into the buffers as well. We didn't set the extents or the center yet, but that shouldn't keep it from rendering. Geometry count. So I guess let's see. While I think about this for a minute, I'm going to catch up on some chat. What's the name of the game? Great year. Yeah, so the name of the game is Overdrive 2069 for now. And yes, the 69 was intended. Couldn't you just make a track in Blender and import it into your engine somehow? Wouldn't that be easier? So that's what I'm going to do for the visual track, right? But what I'm doing here is we don't have a physics system, right? So I'm basically making something that's going to be our track physics for us, because we just need something really simple. We don't need like a full-blown physics system for this, right? So we need something that's simple yet bulletproof. And so what I'm trying to do here is I'm trying to render that so we have some sort of visual reference as to what it looks like, or visual representation as to what it looks like. That way we can, see it in the world, as it relates to the visual scene, which we haven't actually built out yet. And it'll give me a quick way to be able to test the mechanics and get the mechanics in before we actually start making tons of artwork for it, right? Want to work a bit on basics. Do you have recommendations for common data structures, string processing, read materials? Mario Kart with katanas. I don't hate the idea, actually. Katana would be a neat weapon. Do you have recommendations for common data structures, string processing, read materials? String processing, not really. I usually just look at examples of already existing stuff out there if I need to know how to do something. There is this book as far as data structures and algorithms. It's literally data structures and algorithms in C++. You could probably translate most of this to C. I happened to buy the C++ version because that's what I was using at the time. But it's by Clifford A. Schaefer. And this is a pretty decent book. So yeah, if that's what you're talking about, that's a pretty decent place to start. Let's see. How did you learn to build a game engine? Is that your full-time job? It was at one point, yes. I don't do that for a living anymore, but yes. I did make game engines for a living. Is there a reason you've gone with C and not something like Zig or Odin? Language simplicity, and every time I look at one of those languages, I go, why wouldn't I just use C? C is what I'm comfortable with. It's what I prefer. And so I stick with it, right? Stick with what you know. I haven't had a compelling reason to move over to them yet. Zig's syntax, I don't particularly like the way that it is. And Odin, I don't know. I've also not seen a very large-scale project released with it. So I'm not sure as far as that goes. It's only been, relatively small code bases released with that. Not that this code base is huge, but it's going to be pretty big by the time we're done with it, right? I could be wrong on that. I'm just not aware of anything that huge that's released on it. All right. So what was I going to look at? I need to look at, I guess, probably where we do execute. If I don't see anything in here, I might just pull up RenderDoc because it's possible that our vertex and index data is foobar. So let me do, what I want is render scene. And then when we go to render when we go to actually render the individual meshes, I've got a lot of dead code in here I need to get rid of. Static geometry, so here we go. So it should be part of this, right? Interesting, we're not hitting that breakpoint at all. Okay. Is execute just not being called on this node at all? It's not. Okay. How is that possible then? It's running, is it not? Oh, I had it paused. That would be why. Okay. Dingus. All right. So geometry count is 3. Okay, so that aligns because the tree trunk is 1 geometry, the leaves are another, and the track should be the 3rd. So let's do this. So this is the first one, second one, third one, right? Okay. So we have material instance. Obviously we have to bind that. Material system apply. Okay. We're not using that. Okay, render a geometry draw. So let's step into this. And we're doing render buffer draw. So we're going to draw the vertex buffer, or draw it, right? In this case, it's just going to be binding it. So bind only is true. So we're not going to draw that because we have index data. So that's going to be this guy that's going to go in there and do that. Includes index data. Why did this skip all the way down there? Sus. Okay, so I guess let's take a look at I guess we can say 2. I want to see really quickly. Indices, and I'm going to say I want to look at the first, I don't know, 24. Whoops, got that at the wrong, it needs to be that, and then at 24. Do we not have geometries 2? Isn't it indices? Oh, right, we don't pass that into the render data. Poop. All right, so I'm going to have to go to the next frame, I guess. So we do know it's at least getting passed in here, so we know that at least. Okay, so let's do G. Let's just look at the index data here real quick. Why do I feel like that's not... Okay, it's there. But it's not giving me any data. Oh, because it's a void pointer, that's why. Okay, so this is going to have to be U32 array that we cast to. There we go. Okay. So we have 0, 1, 3, 1, 4, 3. Let's look at our little drawing here. There we go. So we have 0, 1, 3, 1, 4, 3. Okay, so that's correct. And then we have 1, 2, 4. And then we have 2, 5, 4. And then nothing but zeros after that. Seems legit. Okay. So we should at least, and by legit, I mean totally not legit and completely wrong. But we should at least be seeing this. I suppose I could check the vertex data too to see what that looks like. So let's take a look at the vertex data. This is going to be vertex 3D. And so all we're really concerned about is position, right? Well, that's got a position. This one should be the center, which is probably going to be 0, 0, 0. That actually does make sense based off of where the first point is. And then this one is going to be kind of on the other side of that. So far that tracks. Because I think we have a height of 0 on those things. We do have some height on this one. So maybe we don't have the height figured out, but regardless, it should still render, even if it's a little bit flat. Okay, so we should at least be seeing one triangle there. All right, so let me do ye old render doc. Here we go. I need to change this from the testbed to that. All right, and we're going to launch, and then I guess we'll go into the editor camera, and I feel like we should see it here somewhere, but I'm going to space this out a little bit and then do a capture here. All right, and we are going to take a look at let's see. Why are none of my debug names showing up? That's a little bit weird. A little bit sus. Did RenderDoc just crash on me? I feel like it has. Ugh, really? Normally when it does this, things have not gone well. Let me kill it. Because whenever it does that, it just keeps doing it. There it goes. All right, so let's try that again. Probably gonna have to edit this again. Oh, no, it did remember that. I don't know why it does that every once in a while. Kind of annoying. All right, so I'm going to assume it's going to be one of these execute commands in here. Probably, let's highlight the draw call. Okay, so that's the text. All right, so it's not that one. That's the grid. Okay, here we go. So, oh, that's interesting. I don't know what that is. All right, let's look at the mesh viewer. That's kind of sus. Kind of seems like that might be our track. It is 48. 48 indices, right? So that seems like it might be it. And it looks like our data is just horribly wrong. So let's have a look. So it looks like it looks like the positions are just not correct. Okay. And if we look at the out positions, those are kind of suspect too. Our index data is definitely not correct. So I think that's probably the issue, right? I guess what I could do as a test, just to make sure that what we're doing isn't completely insane. What we could do is go into the track, and we could just override some of this stuff temporarily. So what I'm going to do is I'm going to take these things and move them down here. I can leave that there. Put this down here. Put index count down here and put index or indices down here. And then what I can do is I'll just turn this off for a second. So I'll just do if 0. And then come down here and do, let's see, is that, yeah. All right, and then up here, I'll just make like a single triangle or something, right? So I'll do, so vertex counts, we're just gonna do, I'll do 6, right? Or no, 4, right? And then for index count, I'll just do 6. So those two things should be fine. And then I'll leave all the vertex positions at 0. Well, I can't leave them all at 0. All right. I need these again. All right, so we can do that. Verts position 1 is just going to be vertex vector 3 0 0 0. Right, and then we'll do let's see, I guess we'll do 1 here, and then this one will be 1 and 1, and then this one will be 1 there. Okay. And then we'll do indices 0. And I guess we can actually use the same pattern as we were doing down here, right? So we could just do 0 1 3 1 4 3. So 0 1 3 1 4 3, right? Okay. That should give us something to render at least. Point count. Great. Since this is a hack, I'm just going to do this so it thinks it's used. Okay. Run this. Part of the problem actually might be, it might actually be Z fighting with the water plane. Let's disable that. But we should see that, I would think. Yeah, and I don't see that happening here. And we really should. Oh. There it is. Oh, and that's wrong too. Okay. All right, so winding, maybe? It kind of works, but it's kind of foobar, right? What does the wireframe look like on that guy? Yeah, okay. So I think it's a winding issue. So let me just think about this for a second. So we have 0, and then we do x-axis, right? So we go this way, and then up. Right, so that's going to be 0, 1, and 2. And then if we do, oh yeah, this is wrong. This is wrong for what we have here anyway. We should have 0, 1, 2 is correct. But then we need 0. Oh, 4 never exists. What am I doing? It should be 0, 1, 2, 0, 2, 3. More dingus-oriented programming there. That was exactly it. Awesome. Okay. I'd rather teabag a bucket of glass shards than eat hot sauce. Oof. That's man, I understand not liking hot sauce, but that's extreme. That's pretty extreme, not gonna lie. All right, there's our quad. So, yeah, it looks like our winding is backwards on it. Not a huge deal, we can fix that. So this makes me wonder. This makes me wonder if I actually did get the indexing wrong before. I guess let's just test this theory one more time. So, if we wanted to reverse this, we would do 2, 1, 0, right? And 3, 2, 0. There it is. And it is Z fighting, but that's fine. Okay, so our single piece of geometry works there. So now how do we get from that to what we have down here? So let's delete that. Let's go down here, delete this, and rethink about what we're doing here. Because I'm pretty sure this loop is just wrong, and that's probably why it's not working. All right. That's how much I like GDB. Nice. I gotcha. All right. Okay, so this is each segment. So for every segment, we have tessellation. You know what? I'm going to rename... I'm going to rename that because I really want this to be T. Thank you for the follow. Appreciate that. All right. So this is our percentage through the number of segments we have. We only generate index data for segment resolution -1, essentially. Which also does make sense. Okay. I'm pretty sure the vertex data... I'm pretty sure the vertex data is right. I have a feeling this is where we're actually going wrong. So, oh yeah, this actually is... So what did I do up here? 210, 320. 210. 320. Yeah, my numbers here were all kind of foobar. I don't know that that's going to fix it, but let's give it a whirl. So the start of the track should be around here, but as you can see, we still don't have anything that's visible. I don't even think wireframe mode is actually going to show us anything. Oh, there's something right there. There's a piece of it. Okay, so obviously it is showing up. It's just completely wrong. All right. So if we think about this, this essentially looks forward to the next tessellated face, so we skip the last iteration. I think that's still going to be relatively safe to do. I wonder if we should even bother doing that, though. So the index, I guess let's just walk through this, right? So on the first iteration through here, on our first point, we're going to get the first 2 points, actually, right? So we're doing point -1, so this is technically a segment, right? This is per segment. Segment consists of 2 points. So we have a start and an end point. That's basically the first and second point. For each of those, we have a tessellation within that, right? And in our case, we set that tessellation to 1, I believe. So we should only ever go through this loop actually twice, because this is less than or equal to. So we need to fill out that tessellation from beginning to end, and if we want one segment, that still means that we need to go through this twice, right? Because we generate basically these 3 at a time, right? So we generate these 3, then we generate these 3. But on the first iteration, we generate these 3, and we generate the indices for both, right? And then on the second iteration, we don't do this one. So, this I'm pretty sure is correct, right? So vi is the vertex index. That's the index into the vertex array. I guess we could say that's going to increment by 3 for each one of these tessellations. That makes sense. I think this is correct. And then the index, we need 12 of them. Wait. I don't think that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that is correct. Okay, so we do need 12 of those per tessellation, right? So the tessellation includes both of these, plus potentially more. Thank you for the follow. Appreciate that. Are the 4, 5, and 6 indices correct? That's what I'm wondering. You're thinking these are probably wrong, right? So index 0 is going to be vertex 0. Index 1 is going to be vertex 1. Index 2 is going to be vertex 3. So, oh yeah, these are wrong. I think I had these right before. So 0, 1, 3. 0, 1, 3. And then we're going to do 1, 4, 3. 4, 3. Right? And then for the other half of that, we're going to do 1, 2, 4. And then 2, 5, 4. So yeah, I think that's correct. And it should be the vertex index. Oh. We can't simply use the vertex index here, I don't think. Or can we? So for the first iteration of this, when we come through on the first tessellation, that's going to be 0, right? So we're essentially going to wind up at the correct indices for all of these. And these should be correct too. I think I need to debug this just to see what's actually getting generated. I need to step through it, I think. Let's do that. Let's put a breakpoint there. All right, let's move this over a little bit so we can see what the heck we're doing. All right, so the index is 0, and the vertex index is 0, right? So our indices array all the way through should be correct. So let's do, I guess let's look at 24 of them, right? Because that's ultimately where we're going to wind up. So we have 0, 1, 3, 1, 4, 3, 1, 2, 4, and then 2, 5, 4. Okay, so that makes sense. That's actually all we should need for that, I believe. So the next iteration is not going to generate vertices. It's only going to generate indices. Right? It's because that's not going to run. And that's what it should do. It should skip that, right? Because this looks ahead. And then the next point the vertex index for that should be 6, right? So if we actually take a look at, where was it? Where'd it go? So it should be vertex index 6, which would be, wait, is that right? It would technically need to start at vertex 3. I think. Because we're on the next segment now. Oh, no, it would be vertex 6. Because we duplicate the vertices here. So that is correct. What's going on with my debugger here? Why is it? Has it just completely pooped itself? It looks kind of like it did. Nice. Hello. Looks like my debugger crashed. Software is just so well written these days. I just... I can't even like quit debugging it, I don't think. Let me try killing the actual window itself, maybe. All right, htop again. It's really annoying when your debugger fails. All right, does it come back yet? No. I might actually have to kill code. That's really annoying. Let's see. Wow, I've never actually seen the debugger lock up this hard. That's a first. Okay. Let's try that again. Yeah, probably GDB hanging, so VS Code froze. I think so. Yeah. All right. All right, so we know these are correct. And it should skip that. Okay, so we're into the next one now. All right, so the vertex index is 6, and the index is 24. Why would it be... Oh. Now I see. I can't increment this here. I should only increment... Okay, I see what's going on. I see a problem anyways. I don't know that it's the full problem, but I see a problem. So this bit shouldn't be done there. It should only be done here. Because otherwise we're just moving forward in the list even though we're not actually adding anything to it. So that's definitely an issue. I'm just going to run this minus the breakpoint and see what we get. Had it happen many times, yeah. It's just frustrating when your debugger fails like that, you know? All right, I still don't see any winding or any other anything else going on here. In fact, I even see less than what I saw before. Okay. So I guess I need to put this back and try it again. Let's do vertices. And what do we say? I guess we could do, I don't know, 30 of them. Doesn't really matter. What did I call this? Was it just... Oh, I called it verts. That's why. Okay, so I wish there was like a quicker, easier way to look at these, but let's see. I'm pretty sure the first ones are correct. Let's see what the second one looks like. These are all 0. Are these two 0? Well, that one's going to be because it's the center of the first point. That makes sense. Okay, so that's fine. Oh, right, because we haven't run through the loop yet. So I guess that does actually kind of track. We'll leave this one open and see if it gets modified on the way through here. So we've got our left, our right. This should modify position 3. Yes, it does. Okay. That, though, looks just like... I could be wrong, but that looks exactly like position 0. It is. It's the same. That is why. So we are generating the geometry. It's just all on top of each other. Why has that happened? Okay, so center should be... Oh, dingus. All right. Do you guys see the problem? Womp womp. Ruche dropping these nuts. All right. Let's try this now. Oh wait, did I build that? I'm losing track of what I did now. Let's just let this load. Aha. Okay. So we're getting somewhere. In fact, okay, so our winding order is wrong, right? And it looks like we might have an off by 1 issue, but I see geometry, which is awesome. We have 3 segments too. I'm not sure why the interpolation here is weird. So it seems that there's a bug there. And it looks like I need to reverse the winding, which I can just actually do very easily when we go to render the thing. So, in fact, I think I could just do this. That way we can actually see what it's actually supposed to look like. Okay. So, all right. So the first one is Z fighting the water. That makes sense because of the way that it was put in there. But the rest of the geometry looks mostly correct based on what I entered, right? Because I did kind of have like varying heights and stuff like that, or varying heights and widths. So I don't believe, though, that Oh, I know what part of the problem is. If we go into... let's see, it's going to be track load. Or actually, it's probably going to be initialize. We are doing our track points here, right? I don't think I put rotation on any of these because I didn't actually initially have that in there in the structure. So we have, we need rotation. So for now, I'm just going to do, and this is going to be rotation in radians. So I'm going to do degrees to radians. I'll do 0. Actually, let's do like I don't know, like 13 degrees, right? And then degrees to radians, we'll do, for this one, I guess we'll do like 25. And then degrees to radians, we'll do, I don't know, 45 for the third point. And I guess we can do, I don't know, 60. That might be a little bit too extreme for how close they are together, but we're just kind of doing this blindly. And then also, actually, I want to change how far up this goes and make it a little bit less linear. So I'm going to do 1 for this one, and then I'm going to do, I'll leave that one at 5, but then I'll set this one to like 6 for height, right? Okay. So we built that. Yeah, see, that looks a little bit better. We do need to like set up some texture coordinates and stuff like that. Why? So we've got a little bit of weirdness with our interpolation, right? And actually, wait a minute, that might not be. Yeah, I think it's an interpolation issue. Also, it doesn't look like the. Oh yeah, it is respecting the heights that I put on the lines. I just very slightly tweaked those, so those are correct. But yeah, I think the interpolation between the points is just not quite there. So let me think, why would that be wrong? Oh, I know what I did. Or at least I think I have an idea of what I did. I don't think I'm actually duplicating the points like I should be. What I mean by that is, if we take a look at this guy again, we should have 6 vertices per segment, right? And the ones that overlap are actually duplicated, or they should be. And I don't think that they actually are. I could be wrong about that. But I wonder if, because of the way that we're calculating these positions, if that is just wrong. Because we are interpolating per segment. I think there's like maybe a rounding error or something that's happening. At least it kind of feels like that might be the case. Yes, I accidentally did say a bad word a minute ago. I said VS, and I didn't bleep it. I'm gonna get demonetized now. That's all it is. This stream is just it's a thing of the past now. not gonna be able to run ads on this one. I accidentally said a bad word. I said, VS, and I didn't bleep it like that time. So, oops. Sorry about that. Thank you for calling me out on that one. Enigma Dev, how's it going? Good to see you. Should vertex index be incremented by 6 instead of 3? That's what I was just thinking. So I think we are. Wait, no. This is per tessellation. So technically it would get incremented by 6, right? So every tessellation, we have a minimum of 2 tessellations per, or 2, tessellation's the wrong term. But essentially we have 2 sets of these that get generated per segment. So the segment is like one of these blue things, right? Between 2 lines. And so our loop is actually less than or equal to the segment resolution, right? So our segment resolution is set to 1, which means that this loop runs twice, which is what we want. Sorry, not that loop, this one. And so the first time we run through, it gets incremented by 3 because we generate 0, 1, and 2. And then the second time we generate 3, 4, and 5. And we only generate indices, though, up to the last iteration, right? So our iterator has to be less than this, not less than or equal to, right? So this does not run in the last one. So I think this is actually correct. I think we're just doing something stupid here. And I don't know exactly what that is yet. Because this should essentially be 0 the first time we pass through and 1 the second time we pass through. Do we have, let's see, left width? We're interpolating between the widths from the start to the end, right? So the start here is the first point, the end is the second point. Are we doing anything else by I in here? I don't think we are. Okay, so I think we actually got like all of this right. I think it's probably just something that is not quite correct in here. Did it take my rotation into account, now that I think about it? It should be. I need to look at it from above just to make sure that it's actually doing what I think it should be doing. Let me see, I'll align the camera this way. Yeah, that is doing the thing. It just looks a little bit awkward because of the positions being a little bit weird. Didn't I say there was... No, I put rotation on the first one, right? I think. Yeah, I did. So 13 degrees, 25 degrees, 45 degrees. I mean, I think that's roughly correct, given the perspective offset that we have here. That looks a little bit more steep than 13 degrees, though, if I'm honest. But anyway, I do think that we're close. I'm just not 100% sure why. I'm not 100% sure why this middle segment is not aligned like it should be. And I'm wondering if it's just something that I'm doing in here wrong, but it doesn't seem like it is. I suppose I could check my assumption here to make sure that this is between 0 and 1. So I'll do a breakpoint here. Actually, I'll put it here, because my interpolation is based off of that. So if that's wrong, then obviously. Okay, so the first is 0, so that's fine. The second iteration is 1, okay. And that should be 0 and then 1. Yeah, so that should be fine. Let me try... Maybe if I bump this up a little bit. Let's just give this a whirl and see how it works, right? So we'll just do... let's do a segment resolution of 5. And just see what this does. Let me get rid of the breakpoint. And we're just going to load that up and see if it actually does the thing. Yep, it does. But the beginning and the end points are still wrong. So it looks like in between the actual thing itself, like the actual tessellation is done correctly. But just where it matches up in the end is just wrong for some reason. And I think my vertex indices are all... my vertices and my indices are correct. I think it's just like a positional thing that's wrong. Something with the way that I'm doing all of this stuff just isn't quite correct. Let's see. Do I have any stupid copy pasta in here anywhere? So the left side... Oh, you know what? I might have my left and my right mixed up. Left in this case should be negative. That might explain the winding issue, actually. Plus. I'm going to build this and just run it as is without flipping the winding and see if that actually has an effect. I think it's going to. Yeah. Our winding's reversed. That was the winding issue. Okay, well, at least I figured that one out. So we now don't need to do this anymore. Okay. That then makes me wonder if I'm doing anything in here that's dumb. Like maybe I need to reverse these. I wonder if this guy is just wrong. I don't see anything that I've copy-pasted wrong now. Wendy's. LaFoley, how's it going? Good to see you. Spiro, how's it going? You're on the phone with Bezos right now, calling him to pre-block my game. Nice. Appreciate that, buddy. Just called Bill Gates. He even disagrees with using the term. That's awesome. Yeah, Spiro, I know. Accidentally said it live on stream. What are you going to do? What is the name of the theme that I'm using there, though? I think it's Groovebox. What was it? Groovebox Dark Hard. Yeah, and it's with the Groovebox themes plugin. Okay, so I think we did make some pretty decent progress tonight. So I'm going to put a pin in this for tonight, and I'll probably go ahead and push up the code as well. For now, I am eventually going to separate this into a different repo, but I haven't exactly decided how I want to do that yet, so I'm going to wait on that. I'm going to bat away the ads for right now. And LaFoley got the ban hammer for a second there. Oh, that's hilarious. Good going, Spiro. All right. So I think this is where we're gonna leave it for tonight. Like I said, we made some pretty good progress, and we had to go through and explain a bunch of stuff too. So I'm pretty happy with this. We are going to have to figure out some issues here, but at least we have like a kind of track showing up. So I'll see about maybe coming up with some better points and rotation and stuff so it actually resembles a track. And then we'll see about getting like probably a cube to move around along it and follow along and actually be able to have it be bound to the track, because that's going to be the first important mechanic we need to get working to get everything else. So, all right, let me see who I can raid. Spiro's in here, so I don't think he's online. Unless he wants to be. Oh, I know who I'm raiding. All right, and he's probably going to raid me if I don't raid him, so we are going to raid Els Dragoon. It's actually two guys. They're working on an NES game in 6502 assembly, which is super interesting, so whenever they're on, I always like to raid them. But yeah, If you guys haven't already, toss me a follow. I appreciate it. And I will see you guys on the next stream. Thanks for being here. See ya.